In the German city of Cologne in 1888, a man named Andreas Flocken climbed aboard a furrow-wheeled wooden carriage. He pushed a primitive steering mechanism and the carriage began to move. No one on that street knew they were witnessing the dawn of a battle that would span more than a century, a battle for the very heart of the automobile. 10 motors, 10 bold engineering decisions, and the story of how each one solved a problem that others simply could not. Motor 1. The Flocken car motor, 1888. It was a simple direct current DC motor, producing no more than a few hundred watts of power. However, it proved that electricity was capable of moving a heavy human body on a real road, not just on a laboratory test bench. Interestingly, this vehicle preceded Carl Benz's internal combustion engine car by roughly just 2 years. This means the race between the electric car and the gas-powered car started almost simultaneously from day one. Electricity did not arrive later as a delayed alternative, as many people assume. Motor 2. Porsche's in-wheel motors, 1900. Long before Ferdinand Porsche became an iconic name etched into the history of sports cars, he was a young man working for an Austrian company. He introduced a concept that was shocking for its time, mounting a small, independent electric motor directly inside each front wheel, entirely eliminating the drive shaft and the traditional transmission. His car, the Launer Porsche, was unveiled at the 1900 Paris exhibition and left the audience absolutely stunned. This idea vanished for decades, only to suddenly resurface more than a century later as the foundation for modern designs, championed by today's startups seeking to eliminate the transmission once and for all. Motor 3. The series motor. The first golden age, 1900 to 1920. During this era, electric vehicles made up nearly a third of all registered cars in the United States. They were specifically marketed to women in urban areas because they didn't require the notorious heavy hand crank to start, nor did they emit smoke or smell like fuel. Companies like Baker Electric and Detroit Electric relied on a simple, high-torque series motor right off the line. But this golden age collapsed abruptly with the invention of the electric starter for gasoline cars in 1912, which eliminated the need for the hand crank. Coupled with a sharp drop in crude oil prices, the electric car practically vanished from the streets for a full 70 years. Motor 4. The General Motors EV1 motor, 1996. After a 70-year absence, the electric car returned through a project that sparked a controversy still echoing today. The EV1 utilized a single 3-phase AC induction motor with an output exceeding 100 kilowatts, an astonishing figure for a car of that era. But the story didn't end as a technological triumph. It ended in an industrial scandal. General Motors eventually decided to recall every vehicle from its lessees and literally crush them in the desert, despite protests from users who loved their cars and tried to buy them at any price. This decision later turned into the famous documentary, Who Killed the Electric Car? But more importantly than the controversy, the specific engineers behind this motor moved on to lay the foundation for everything that came next. Motor 5. Alan Cocconi's motor and the T0 car. One of the engineers who worked on the EV1 project, Alan Cocconi, founded a small company called AC Propulsion. He built an obscure, experimental sports car called the T0. Using an improved induction motor, it could launch a lightweight sports car from 0 to 60 miles per hour, 100 kilometers per hour, in under 4 seconds. This happened in an era where those numbers were strictly reserved for luxury supercars chugging massive amounts of gasoline. A group of Silicon Valley entrepreneurs saw this little car and were so impressed that they licensed its entire motor technology for their own startup project. Motor 6. The Tesla Roadster motor, 2008. That startup project was Tesla. Their first car, the Roadster, used an upgraded version of that very same induction motor, with technological roots tracing back to aerospace applications, where motors must withstand extreme heat and maximum rotational speeds without failure. Choosing this specific design wasn't just a technical coincidence, it was a brilliant strategic decision. It completely eliminated the need for rare earth magnets, metals where over 90% of global mining is concentrated in China alone. By avoiding them, Tesla prevented itself from becoming hostage to a complex and unstable geopolitical supply chain. Motor 7, the copper motor in the Tesla Model S and X. When Tesla moved on to produce its luxury Model S, they amplified the induction motor's power by using a cast copper rotor instead of the traditional aluminum one. This significantly reduced electrical resistance and boosted efficiency. The beautiful irony here is that the shape of this cylindrical rotor with its internal windings is exactly what inspired the company's logo. Millions of people see it every day without realizing they are actually looking at the cross-section of a real electric motor. Motor 8, the permanent magnet synchronous motor, the overwhelming choice. While Tesla held on to the induction motor for years, almost all other major automakers, from Nissan to BMW to Hyundai, chose a different path: the permanent magnet synchronous motor, PMSM. The reason is simple and decisive. This design offers noticeably higher efficiency at lower speeds. In practical terms, this means a longer driving range in daily urban stop-and-go traffic, which is exactly the environment where most cars spend the vast majority of their operational life. Motor 9, the hybrid motor in the Tesla Model 3. In a striking shift that flipped industry standards, Tesla abandoned its old principle and introduced a motor in the Model 3 that combined permanent magnets embedded within a specially designed iron core. This was engineered to exploit a phenomenon called magnetic reluctance, an additional force generated by the shape of the iron core itself, independent of the magnets. This fusion of two technologies resulted in lighter weight and higher efficiency. It was so successful that it later pushed even the Model S and X to adopt a modified version of it on the front axle, while keeping the original induction motor on the rear. This created a hybrid design that offers the best of both worlds, adapting seamlessly to real-time demands for speed and load. Motor 10, axial flux motors, the next generation. Now we arrive at the latest chapter of this journey, a technology where the magnetic field moves parallel to the axis of rotation, rather than radial as seen in all previous designs since 1888. The result is a motor that looks like a remarkably thin metal disc. It is vastly lighter and boasts a higher power density per kilogram than any design before it. A small British company named YASA quietly developed this technology for years, until Mercedes fully acquired them in 2021. This was a clear signal that industry giants are betting on this design as the near future. The strongest proof came later when Mercedes used a motor derived from this technology in their famous concept car, breaking energy efficiency records by traveling over 1,000 kilometers, over 620 miles, on a single charge. From a slow wooden carriage powered by weak electricity on a German street over 130 years ago, to a razor-thin metal disc propelling an ultra-efficient car across the equivalent distance of a cross-country road trip on just one charge. This is the true story of the electric vehicle. It is a story that has never been adequately told through batteries alone. It must be told through that metallic heart, pulsing with magnetic fields. The motor. The silent hero that transforms electrical charge into real, kinetic life on the open road.